Favourite companies? SUSE.
Oh,
I was using that distribution. Because they were ones actually, they had proper documentation. And you needed it back then. Yeah, so,
amazing how hard we documentation.
yeah. No, I remember it was like, we had a couple of code. Yeah, the print server function. And it's kind of works a bit like Kubernetes, really. So they actually had a whole section on debugging. So you do it manually. Oh, that's the step I missed out. So it's a thing, I can't remember what I did last week. I remember that.
Like, do you know those?
No, I don't know. I know SUSE. I was
Yeah, Charlie, I'm from Styra.
Oh, amazing. Okay.
I just wanted to let you know.
You're going to come and do the.
Well, yeah, I was just going to say, like, that's all I've really got to say. But yeah, that's all right. Yeah, just want to let you know that I'm here.
Amazing.
Yeah.
Do you want to say something like
Yeah,
and then,
small thing,
yeah, I mean, it's very
yeah, that's so. Okay, yeah.
Okay, thank you.
Well, she looks ecstatic.
Cool.
Sorry for the doubt.
Is this actually from something, or I don't know.
So she looked ecstatic.
I have a co-host, a lady with eggs.
Come on down, come on down. There's seats at the front. If you're sort of got a gap, maybe you can move that way so that people can squeeze in as well. Yeah, come sit at the front with me. Amazing. I'm so happy that you all found this place because, well, with the train strikes today and with us moving to a new venue to this Just Eat offices, I was a little bit worried that nobody would show up. So I'm extremely happy to see everyone here tonight. So we can get started. This is Cloud Native London. We'll tweet, if you want to tweet, you can tweet with the hashtag Cloud Native Lon. We are a strong, open, diverse developer community around the cloud native technologies and platforms in London. I'm your host for tonight. I'm Cheryl. You can find me at Cheryl on Twitter as well. I'm a senior director at ARM, and I've been around the cloud and Kubernetes communities for a little while. Tonight we've got 3 talks. So the first one at 6:45 is running cost and performance efficient and analytics application the Kubernetes way by leveraging Volcano. 7:15, how SUSE helps you accelerate your cloud native journey. Then we're going to take a 15-minute break and come back here at 8 o'clock for unknown unknowns and how to know them. And then at 8:30, we're going to wrap up and we will find a pub around here if you want to hang out a little bit more. Okay, so thank you to tonight's sponsors. I'm going to read out a little spiel for SysDig, unless there's someone here from SysDig tonight who wants to do it. And then I'm going to hand over to others to do the rest of the sponsor shout outs. So SysDig is driving the standard for cloud and container security. With SysDig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. Charlie.
Thank you. Yeah, microphone and everything. Hi, everybody. I'm Charlie. I'm from Styra. I've recently joined only 2 months ago. I work in developer relations. I work on OPA, or Open Policy Agent, which I'm sure some of you are maybe familiar with or using. I'd love to talk to you. It would make my day if somebody came up to me and said, hey, I'm using OPA, I'm having this trouble, or I love it. Just tell me anything. I would be really interested to hear about it in the break or afterwards. Thank you.
Thank you very much. Just Eat. I don't know if Stephen is here, wants to say a word or two. I can wait till later. Oh, thank you. We are extremely happy to be here. SUSE. So Nelson, who's doing our second talk, you're going to do a bit of introduction in your talk, right? And then Plug.
Hi, my name is Anna. I'm from Prodina. We are an IT consulting company. We do a lot of stuff for our customers. So mostly with the custom software solutions, with modernization of applications and anything really, because there's more than 400 of us. We are based in Germany originally, and we have offices here in London. And obviously we are hiring. So if you know or are a DevOps engineer or any full stack engineer, we are open, and you can talk to me later or my colleagues. So we are here to talk about anything or problems that you have, technical ones. Obviously not me, I'm in HR, but whoever can help.
Amazing. Thank you. Thank you to all of our sponsors who pay for pizza and beer and make it possible to run these events. Next week, I think it's next Wednesday, Thursday, or Tuesday, Wednesday, there's a conference called State of OpenCon, if you're interested in open source. They're offering us 5 free tickets to this conference. If you want to claim a ticket, then message me on Meetup or on Twitter with your email address, and I can get you a free ticket. Okay, right. Now we're going to switch to a bit of live polling. So if you've got a phone with you, then please grab your phone and go to this link, ocheryl.com/p. And I'm going to ask, it's going to direct you to this poll everywhere service, so you don't need to download anything, but I'm going to ask you 2 questions about you and then 3 questions about how you use cloud native. I apologize that the Wi-Fi in here is not very easily accessible, so you probably have to use data. We can get you on Wi-Fi, but it requires someone to approve you from Just Eat, so it's not very open. Okay, ocheryl.com/p. And first question, is this your first time at Cloud Native London? Okay, people are already figuring out there should be a yes and a no option. And it looks like, ooh, we're going 60% yes, first timers, 40% no's. Still some people, give a second for people to figure it out. Also, we're live streaming to YouTube and to Twitch, so there might be people at home who are voting on this as well. The yeses are definitely picking up, like 65%. Nice. I'm really happy to see that there's quite a few first timers here, so I'm glad that you're here. Next question, what's your job title? So just pick whatever's closest to what you do. Your options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And looks like SRE and DevOps engineers slightly putting ahead. Other can be lots of other things, I guess. Nice, we've actually got quite an fairly even split tonight. Nice to see some different developers as well as infrastructure people. Okay, this question comes from our first speaker. How many data processing/data analytics applications do you run in Kubernetes? So 0, less than 10, less than 50, or more than 50. A handful of people coming up with more than 50 here. Where is Srivalsan? Hey, so what do you think of these results? Is this what you?
I was quite expecting it to be less than 10, but I was expecting this to be
Yeah. I mean, I think whoever's voted for more than 50, you definitely go and talk to Srivalsan. And I guess if you're running 0, then we'll find out a little bit more in your talk. Okay, next question. Are you running Rancher today? So yes, running Rancher in production today. I even have a support contract. Yes, in production, just testing the water, or running what? Nice. So Nelson, this was your question. So I guess is this what you were hoping for?
I like the last question. It means we can educate people. But
Yep.
it's good to
Yep.
know that people are using it without us knowing. You don't just open source, we get a lot of people downloading it for free, and we have no way of knowing who's actually using it. So it's loads of those actually being used without us even being involved. So,
Yeah, definitely. I mean, just that's one of the things I really like about open source, you know, that anyone could just download it and try it and kind of get started. So hopefully the 77% as well will learn a little bit from your talk. Last but not least, the last outage I dealt with had a simple root cause. Strongly agree, disagree, or strongly disagree. So what's coming out here? Oh, 55%, 60% saying agree. Only 10% saying, actually, well, yeah, a lot of people are saying, yeah, it's a fairly simple root cause, I guess. Where's Dylan? Yes, Dylan. Do you think this looks fine?
like my talk then, but we'll see.
I'm sure everyone will love your talk. What were you expecting
I was
when you do
expecting
this?
more on the strongly disagree, but there could be a couple of reasons why, which I'll go into.
Okay. Look forward to seeing that then. All right. Oh, thank you everybody for doing the live polling. Keep it up because I'm gonna do the questions. We'll do Q&A through the live poll as well. But for now, I need a selfie for the purposes of social media. So just smile and wave for me. Okay. Oh, thank you. Okay, and Cloud Native London itself, if you want to come and speak, I think this is out of date. We might be at like December 2023 now, but please go to cloudnativelondon.com. You can request a speaking slot. You can come and sponsor. You can share your own events if you want to. So cloudnativelondon.com. And that's it. So I'm going to stop here, hand over to our first speaker. Please round of applause for Srivalsan.
Thanks a lot, Cheryl. I hope I'm able to share my screen and it's visible in Zoom. Thanks a lot, guys, for joining in. What will be, I think I kind of give you a glimpse of the whole PPT by just going back. But what I'll be speaking today is how do you build cost-efficient, highly performant analytics applications in Kubernetes, and how do you leverage Volcano? So just before getting into this talk, how many of you guys, I mean, I do see a lot of people who have actually started using Kubernetes. Have you ever come across Volcano? Has anyone come across Volcano? Cool. So I thought for some people it's going to be a talk which they already knew, but I think there's something which is there for everybody. That's quite great to know. Yeah, so just before that, my name is Srivalsan Mannoor. I work for Amazon Web Services as a cloud architect, and all the contents of whatever I'm going to speak is personally my own. I don't represent the organization in any way. So that's that's the thing which I have to put in. Great. So let's move on into the topic. So right. So if you kind of look at analytics applications, a lot of analytics applications is out there right now, and basically what they're looking for is it's quite data intensive, which means that the application requires a lot of resources to run, and it basically processes a lot of load, and it's basically sporadically analyzed, which means that you would need resources quite intensively. You would need it at any point in time. You have no idea when you're going to get certain resources. So that's basically the expectations of how an analytics application would kind of run. So if you have basically run those applications before, and usually most of the times the analytical application runs on Hadoop. So if you kind of look at any analytic applications, it would essentially be running on a Spark, and it would run on top of a Hadoop yarn infrastructure. I mean, I'd probably not get too deep into it, but Spark is basically an analytic processing engine which is run on a Hadoop ecosystem to process all of the analytics applications. What's actually happening is that the Spark, if you're running any analytics application, it's quite resource intensive, which means that you would not be able to efficiently manage the infrastructure. So you basically have to spin up certain instances, and you have to install all the components on top of it, and then you basically have to run Spark applications on top of it. And that's where the so you would be able to run those instances, but then it's actually quite cost intensive, which means that you're basically running many instances, and you're doing a lot of performance tuning in terms of Spark, but you're not basically getting all the power of the instances which you're actually kind of using. And that's where a lot of organizations kind of see moving towards Kubernetes applications. So right now, a lot of applications who are actually doing their Spark on Kubernetes applications. So, I mean, I do see a lot of people who have actually started using Spark on Kubernetes. Can some of you give a view of like how do you feel running Spark on Kubernetes? Any pain points which you're kind of facing? Do you see any improvements in it? Any quick word? Okay. 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 Right. Right. Okay. So I mean, it is to a certain extent challenging, but what I probably would cover more is what benefits do you get when you're kind of running Kubernetes. Essentially, what you would be doing in running a Spark applications is that your infrastructure only can handle Spark application. You will not be able to use any of those resources for any other purposes, for that matter. What's actually happening is that a lot of organizations are moving towards Kubernetes, because what you can do is you can basically create pods out of Spark executors, and then you can actually run along with any other applications as well. So you basically would be having a certain instances, and then you would be running Spark applications on top of your other applications, which is probably your microservice application. So what you're essentially creating is an ecosystem, a resource intensive ecosystem, which basically would start handling Spark applications, would start handling your microservice applications, would start handling your event-driven architecture applications. So you're basically creating an ecosystem, which in a way becomes a lot more cost effective, because you are reusing the resources for multiple other applications as well. So that's one of the reasons why a lot of organizations are actually moving towards Kubernetes from running on Spark. Not just Spark, you would see a lot of AI applications being moved to Kubernetes, a lot of TensorFlow applications, a lot of other applications being especially batch streaming applications being moved to Kubernetes. So what essentially you can actually do is, the way Spark runs is Spark basically has got executor pods, where like you have a lot of executor which basically runs the jobs, and you'll have a driver which actually kind of monitors all the executors. And so that usually is the way how you run Spark. But what actually happened is that from Spark 3.0 onwards, the Spark have started supporting Kubernetes by default. So from Spark 3.0, you get native support on running Kubernetes. And what they've also done is they basically released a Spark operator as well. So the essentially Spark operator basically kind of takes care of managing how you run your executor pods, how you make sure that the driver can actually manage all the executor parts, how you kind of monitor the applications, how you make sure that the application does not shut down into failure. Because beforehand, usually that's the problem, where the driver is actually a single component which kind of manages your entire executors. And if the driver goes down, then you will have a single point of failure. And what they have released is a Spark operator pattern, which then means that you can actually run the entire Spark as an operator. So that's one of the biggest advantages which they kind of came out in Spark 3.0, where they started supporting Kubernetes by default. But essentially, even if Spark kind of supports Kubernetes, there are quite a lot of problems which is out there. Like for example, you will have a Spark UI, which you can actually see a lot of jobs and how the jobs is performing, how much executors are being done, how is the jobs running. And that Spark UI is basically resides inside the driver pod. And because the driver pod is inside the Kubernetes cluster, you will obviously not be able to access the Kubernetes cluster. So you will not be able to access the Spark UI because it runs within the Kubernetes cluster. And one of the way to kind of solve that is obviously like how we kind of expose any pod. You can actually put a ingress controller in front of it, and then you'll be able to expose the Spark UI, to the external world, so that people can actually start accessing Spark UI. The other problem which they kind of raise is that the logs which would get destroyed after the executor pods are actually killed. And especially we have log aggregator patterns like FluentBit, which can actually take all the logs out and then basically stream it into a particular infrastructure, and then you can actually monitor all of those logs in a certain way. And the other bigger problem which is basically being raised by analytics applications is that the Spark kind of runs something called as a shuffle, where you will have multiple different datas, and then the Spark kind of shuffles the data to process the applications, and it also kind of does something called as accessing the HDFS systems to access the data. And that is something which is not natively being supported by Kubernetes yet, but there is a lot of traction after Spark 3.0, where there is a lot of features which is released, which is like it supports dynamic allocation, where you can actually use PVCs and host paths to basically map all of your volumes into the Spark application. Right. So, but the biggest problem which is out there, even if you are running Spark applications in Kubernetes cluster, the biggest problem which is out there in running any analytics application is with respect to the scheduler, because Kubernetes has got something called as a Kubernetes default scheduler, and the default scheduler is designed to only orchestrate long-running services. And the problems you have is you don't have a queue mechanism on the Kubernetes default scheduler. It basically gets the pod, tries to schedule it. If it does not have enough resources, it basically says that I cannot schedule anything. Where there would be jobs which are quite high priority jobs, and there would be certain jobs which are actually not so high priority anymore. And it also does not have a dynamic resource limit, which I'll kind of come back to it later. And you will also, your driver also has got something called as a deadlock, where your driver gets deadlocked, which then means that you'll not be able to run any of the Spark application, because your driver is the main source which actually runs all of the jobs. So if I kind of have to draw an analogy of how a Spark runs, is that you'll have a driver, you basically tell the driver, process 50 terabytes of file, and give me, like, to take a simple example, take 50 terabytes of file of CSV and convert it into JSON format, and then give it back to me for processing. Driver takes that, tells it to all the executors, saying that, you basically take these chunks, process it, aggregate it, and then send it back to me. And the moment the driver fails, it's going to be extremely difficult to handle it. And that's where the scheduling becomes an extremely important factor in Spark application, because it does not kind of help with the default scheduler on how you kind of run Spark applications. And that's where Volcano comes into picture. So Volcano is basically a scheduler which is created just for batch applications. And Volcano is used in multiple analytics applications. It's extensively used in Spark. It's extensively used in AI applications. If you're running any machine learning algorithms, TensorFlow, you can actually run all of those in Kubernetes cluster, but you can actually cover all the shortcomings of the default class scheduler using Volcano. So it basically supports diverse scheduling algorithms, which I'll kind of come back to it later. And it's extremely efficient. It has got extremely efficient scheduling, and it basically supports multi-architecture computing as well. So if you kind of look at the way things are going, is if you are basically looking for any batch application which needs to be processed in Kubernetes, people are actually going towards Volcano because of the benefits which Volcano kind of provides. So in the next future slides, I'll probably tell you what Volcano provides, how it can actually overcome the problems which you kind of face when you're running analytics applications. It's actually a nice name. I'm not sure how they kind of named it Volcano, because initially it's called as Cube Batch, and then they kind of named it Volcano. And the other thing is, because of the advantages which Volcano provides, Spark 3.0 currently has got native support to Volcano as well, which was not the case till 2.x versions of Spark. So if you are kind of running any Spark applications on Kubernetes, I would highly suggest to basically start looking at Volcano initially when you're kind of starting to migrate into Kubernetes applications, Kubernetes cluster as well. Right. So the features, what it basically does is it basically has got better scheduling, which is kind of a common term. It has got something called as a fair share scheduling. When I say fair share scheduling, what does it really mean is it does not kind of like the way Kubernetes works is you basically tell Kubernetes start 10 pods for me. It's going to go check the resources. Does it have enough resources to basically run 10 pods? Kubernetes is going to schedule 10 pods and then come back to the API server and then say that I have created 10 pods. Now, what actually happens is that if there could be two jobs which is submitted to the Kubernetes and say that no, one job tells that I need to have 10 pods running, and then another job says that I need to have 5 pods running, and one job would be a higher priority than the other job. It basically looks at which job is coming, how am I going to schedule it. It's not going to kind of evaluate in a fair share of how it needs to be scheduled the right way. That's something which Volcano provides out of the box. It basically also has got a queue scheduling where your jobs are basically queued properly, and it looks at the weight of the job, which job needs to be handled first. And it also has got a namespace-based cross queue scheduling, which means that you can actually lock down the jobs to a particular namespace, and you can actually allocate certain resources to a particular namespace so that the job has got enough resources to run certain applications. It also has got resource reservations and resources backfill, which I'll probably be kind of showing in the future slides of how it actually kind of achieves that. So this is essentially the, just to give you a view, it's essentially how the Volcano kind of runs. So you have your Kubernetes cluster, and Volcano kind of runs on top of Kubernetes as a scheduler. The way Kubernetes helps is Kubernetes basically supports multi-schedulers, so you can actually run multiple schedulers in Kubernetes. So you can either you go for the default scheduler, or you can actually have your own scheduler and then make sure that how you want your pods to be scheduled. And Volcano is one such scheduler which can actually run on top of Kubernetes, and you can make sure that you can pick services. So like if you kind of look at it over here, you can actually see that the microservices, you can make the microservices to adopt the Kubernetes default scheduler, because you really don't need that heavy lifting scheduling mechanism which is needed. And you can actually make sure that your PyTorch applications or your Spark applications is actually using the Volcano schedulers to get the benefits of the Volcano schedule. And it basically, so it has, this is kind of the architecture of Volcano. So it basically has got the job queue pod group, and the way how the pod group works is just to give you some insights around it. When you kind of submit a Spark job, it's basically going to tell you that create 100 pods for me, because pods are executors. And until you have 100 executors, Spark cannot process any of those applications. And when you're going for a default scheduler, if it's able to only create 50 pods, default scheduler is going to come back and tell you that I've created 50 pods. I'm not able to create 50 pods. So let's basically just run with 50 pods, which kind of defeats the purpose of an analytics application, because you need 100 pods to run, or there's no point of actually running the job. And that's something which Volcano kind of does it for you. The way Volcano works is it makes sure that there's enough resources to basically create 100 pods. And once it has got those resources, then that's when it actually creates those jobs for you, and then comes back and then make sure that the Spark application kind of runs. It also has got the queue mechanism, which I kind of spoke about, where it kind of makes sure that all the services are actually weighted in a proper way so that the jobs are actually prioritized properly. And it also kind of gives you a VCTL, a command line utility like a kubectl, so you can actually execute certain commands and then find out, you can basically establish certain commands to the Volcano. It's quite easy to install. You have got Helm charts to basically install Volcano, and you can actually use it on top of a Kubernetes cluster. Right, so this is kind of the workflow of the Volcano scheduler. And this is in a way much different than how your default scheduler kind of works. So the thing which actually happens on your default scheduler is if you're basically submitting any job, which means that I want to run a microservices application of let's say, I'm just picking up the example again and again, but it's a more easier way to pick it up, like say 100 pods. The only thing which Kubernetes does is it basically makes sure that is there any node affinity on your pods, to make sure that does it have to run only on specific pods and specific nodes for that matter. And it also basically makes sure that do I have enough resources, and if you have basically defined any resource limits on your pod, do I have those resources to basically run it. what it does is it basically has got, so it kind of gets into your cache, and it kind of goes through all of those processes to make sure that your job can be processed. And when I say job, it's basically a summit to the scheduler which says process, can you start 100 pods for me, which for me to run a Spark application or any analytics application. What it's going to do is it's going to go through the session, and you can actually see there it has got 3 plugins. It has got multiple other plugins, but those 3 plugins are actually quite important in terms of how Volcano kind of schedules it. To start off with is the Gang plugin. So what Gang plugin does is it basically makes sure that the user has told me that I have to create 100 pods. So either I am going to create 100 pods in a gang, or I will not be creating those 100 pods. I'll basically wait for the resources to be there for me to create 100 pods. So that's a Gang plugin, which is quite important for any batch application. So that is how Volcano makes sure that if you're publishing any job, it will make sure those number of executors are actually created. And then you have the priority plugin. So the way priority plugin works is, if you're basically defined, so when you create jobs, you can actually define priorities on your job. So this is a higher priority job, and this is not so high priority job. So when it goes through the queue, it figures out, so this is higher priority job. So I need to kind of grab more resources for this job compared to any of the other jobs for that matter. And the other one is the DRF plugin. So the DRF plugin is basically, it's called Dominant Resource Fairness plugin, which was there in Yarn and Meso. So Yarn actually extensively uses DRF, which for some reason is not there in Kubernetes. The way DRF works is it kind of understands what is the resource which you're actually asking for, and is there a fair share around it. So for example, if there is one pod which basically asks for 1 CPU and 100 M of memory, and there's another another pod which actually asks for 3 CPUs and 50 megabits of memory. So what DRF does is it basically has got certain evaluation where it figures out that which pod needs to be scheduled first. It's not going to be, there is 3 CPUs which is basically asked for it, so it is more resource intensive, so I should basically give resources to that. It doesn't kind of work that way. It basically goes through a certain algorithm which figures out how many CPUs are already available on the cluster, how many CPUs the pods are actually asking for. Is it a fair share to basically schedule the pods, which pod needs to be scheduled on a fair way. So that's called as the DRF plugin. So all of those plugins basically are evaluated, and that is how your job is basically scheduled, apart from being scheduled right immediately or being half scheduled and then say that, no, I can only do half of the process because I only have that much resources. There's quite a lot of other plugins out there, which I'll probably just get into it in detail. So this is one thing which I was actually talking about, which is the group scheduling one, the one which I spoke about. So when you submit a job which has got 5 tasks, the default scheduler basically figures out how many can I schedule and schedules it. But this is the other one where the Gang plugin kind of takes care of it. It makes sure that all the tasks can be scheduled, and once it's scheduled, that is when it actually processes the job and then schedules it. And it is extremely effective when you're actually running the machine learning algorithms, when you need certain number of infrastructure for you to kind of run those many algorithms, where you cannot basically run with half of the infrastructure is actually required. The other one is, so this is something which I spoke about in terms of DRF, which is dominant resource fairness. So you have a job which basically asks for 1% of CPU, 4% of memory, and 2% of GCPU. And there's another job which basically asks for a different resources. It basically does a fair scale. It runs an algorithm which figures out which job in this case needs to be scheduled. And that algorithm then decides that probably job B is the one which needs to be scheduled based on the resource which is asked for, and not just the resource which it asks for, also the resource which the Kubernetes cluster has got access to. And that's how it schedules, rather than picking up one or the other. And the other one, which something which I kind of quite interested in, is the bin pack algorithm. So this bin pack algorithm, the way it works is, if you're actually submitting a job into a Kubernetes default scheduler, what it's going to do is it finds a node which has got resources and it schedules the node for you. The way Volcano runs is, it basically, if let's say you have 2 nodes which are running containers. And there is one node which basically has got 40% space, and there's another node which basically has got 90% space. Or let's take another example where there's one node which has got 90% utilization. There's another node where you have not been used at all. So what Volcano is going to do is it's going to make sure that your existing nodes are fully used till that point in time. So if there is a 40% space over here and there's a 90% space over there, and if your job requires 10%, it's going to schedule on your node B rather than on node A. So it makes sure that your nodes are actually fully utilized before it actually moves to the next node. And that way, what you can do is your resource being used can be reduced quite a lot, and that way you can actually get a lot more cost efficiency and performance as well when compared to the normal way of scheduling, where it kind of, so when you kind of go towards a default scheduler, there are high chances that the default scheduler is going to schedule your job on node A, where Volcano kind of evaluates it like, can I fit this job into a node B? And if I can fit it into a node B, it's going to basically make sure that fits it into a node B rather than moving into a node A. So that's one of the algorithms which actually runs in the Volcano scheduler as well. So the other one which I kind of spoke about is the queue. So when you're actually submitting jobs, it basically goes into a certain queue, and there are certain spaces which are being allocated for each and every services, and it goes into a certain prioritization, and then it makes sure that your jobs are scheduled based on that prioritization and not on a first come first serve basis. And so that's one of the advantages of actually going through a Volcano scheduler as well. So now that those are some of the schedule plugins which are out there. So there are quite a lot of other plugins which are out there in Volcano as well, which is like, for example, an SLA plugin, where you can actually define how much can this job go into pending state. So if you can actually define a long pending time, which then means that if your job is pending for a quite long time, for like 30 minutes, then it basically terminates the job, because you have defined an SLA that this job can only go into a pending state for 30 minutes. And there are quite a lot of plugins out there in Volcano. So one of the other thing which kind of need to be addressed is that because Volcano has got quite a lot of plugins, there are certain cases where one plugin kind of conflicts with another plugin. And that's one of the reasons why you kind of have to make sure that you define the weight of each and every plugin before you are, before you kind of schedule anything, because it would kind of come into a conflict and you will have some issues around it. So that's something which you need to kind of take into consideration. Moving on to this is a very simple file, the Spark application, which defines your execute driver nodes and your executor nodes. So you kind of call out what's the driver, how many cores does a driver node needs, and how many executors does the driver node needs. You have defined the version. And the way to use Volcano scheduler is, if you go up here, you kind of define, so the batch scheduler. So you kind of call out what scheduler you need to use. So the moment you kind of have to install Volcano on Kubernetes cluster, and then you call out the use batch scheduler as Volcano. And when you kind of submit this application to Kubernetes cluster, the Volcano kind of takes over and then starts scheduling your Spark application by using the Volcano scheduler rather than going through the default scheduler. So it's a very simple, so it kind of works exactly the same way how you kind of deploy any pod. Of course, there are certain additional annotations which is out there, which is specific for analytics applications. But essentially, by using these components, you would be able to run your analytics applications much more cost effective. I mean, you would get a lot of cost benefits when you start moving your analytics applications into Kubernetes, especially because you are reusing the resources and you're not basically leaving the resources just for running analytics applications. And the other one is, the moment you start using the scheduler, you will get a lot more benefits out of it, especially in terms of cost and performance as well. Because what you're looking at is jobs being scheduled in the right way, in the right priority, and in the right allocation. And Volcano is kind of built only for batch applications, so you will be able to get a lot of benefits out of it. And I'm curious to basically know if you have kind of come across anything. And I think I'm pretty much done. I'm open to questions. Thanks a lot, guys. Any? Yeah. Oh, okay. Oh, sorry.
Thank you very much for the presentation. What is the advantage of using Volcano Scheduler compared to cloud native scheduler? Like for GCP, we have cloud scheduler.
Okay.
Using Terraform, we can do the same thing. So what is the advantage of if we compare those two?
So I'm not sure which scheduler you're referring to. Okay, I'm not kind of worked on it, so I can basically give you an answer of how it actually differs. There are quite a lot of schedulers out there, but the thing is, Volcano is the one which is more designed. So Volcano is basically a CNCF product which is designed to basically process batch applications. I'm not sure if you have these features in the cloud scheduler, because cloud scheduler is more designed for making sure that it can process your Kubernetes. It's basically designed to run a Kubernetes cluster, but not really specific to a batch application, because some of these would not make much of a sense if you're running a microservices architecture. Like for example, if you have a microservices application which needs 10 pods, and if your cluster comes back and says that I can only run 5 pods, so I'm not going to run 10 pods, it just doesn't make sense for a microservices architecture, but it makes a lot more sense for a batch service application. That's one of the reasons, if you kind of look at the previous slide, it does not fit if you're trying to run a microservices architecture, but it fits more on a batch application. So if you're kind of trying to run any heavy workload applications, that's where Volcano kind of fits the bill. Any other questions? Oh, okay. So how do you ensure there is no starvation while scheduling of jobs? The Volcano the Volcano scheduler does not take care of instance auto scaling groups. So if you have an auto scaling issue, that's something which kind of needs to be taken care by the Kubernetes cluster which is actually running. So it would not kind of support vertical scaling for that matter, but it actually makes sure that with the instances which is available, how to basically make sure that I schedule the jobs in the right way. So that's more how Volcano kind of takes care of it. So if you're kind of trying to make sure that would I run out of space when I'm trying to schedule job, and that's where you kind of need to start using more of I can talk more in AWS, where you have Carpenter, which basically makes sure that you can actually spin up more instances. So you kind of have to rely on that to make sure your instances are available. But what Volcano does is make sure that your jobs are scheduled the right way and prioritized the right way. Hope I'm able to answer that question. Any other questions?
One more.
Right. So if you kind of look at it, so I mean, because I gave another example where if you have 2 nodes, what it does is the reason why it actually uses bin stack algorithm is because when you're actually making sure that one node is more utilized, then you're actually having another node which has got more resources, so that if there is any heavy workload application comes in which needs those resources, it can be utilized. For example, you would not be able to, let's say you have 2 nodes and you have memory in both the nodes. You cannot basically run one pod spanning across both the nodes. But the reason why it's actually doing the bin pack algorithm is to make sure that it has got enough resources, so that when a pod or a job which requires more resources comes into picture, it has got those resources to basically run on a single node. That's one of the reasons why it kind of efficiently uses the bin pack algorithm. Hope I'm able to answer that question.
So, round of applause, please. So next up, I would like to welcome to the stage Nelson. Good catch. All right. For the people sort of standing over there, there's like 1 seat here. There's, I think, 1 seat there. So if you want to scoot around, I think there are a couple of seats. Definitely this one. Someone should come and sit here. All right, over to you.
Very much. Good evening, everyone. I'm Nelson, by the way.
So I'm a sales engineer, pre-sales consultant, solutions architect, any title that SUSE gives me, or gives me the lowest quote on my car insurance for the year. And it's always been my aspiration to also share a stage with Katy Perry, so I'm very impressed with this today. So today I'm going to be talking about how SUSE helps you accelerate through your cloud native journey. So if you don't know who SUSE are a 30-year-old Linux company who provide enterprise support for Linux operating systems. So over that time, if you don't know, that Linux is actually 32 years old this year. And considering that we are 30 years old this year, or last year, we are the oldest company to be doing this in the industry. So within that time, what we've been able to do is develop our Linux operating system to be over multiple pieces of infrastructure, whether it be for dev, data center, cloud, branch, or edge, but also adapt it to be able to fit multiple applications and use cases. So that being either for desktop, for just standard server applications, HPC, even SAP. We're the #1 Linux distribution for SAP, and we're chosen by SAP to actually test their workloads as well. But that's not that cloud native in comparison to Kubernetes. And that's where we've started to branch into recently with further acquisitions and further development into our open source technologies. So if you didn't know before, SUSE are a fully open source company, meaning that everything that we do is 100% open source. How we make money is a very good question. No, we apply enterprise support on top of our projects and be able to share you an enterprise class level of support and consulting services on top of that as well. But Kubernetes, Rancher is a company, I hope you will know, from a very long time in the space of Kubernetes, is an enterprise container management platform. SUSE acquired Rancher in 2020, looking at my colleagues over there. And since then, we've adapted it fully into our portfolio. So that by embedding SUSE into it, whether it being a container-based images to be able to easily deploy using Rancher, or even acquiring more software to be able to integrate into it as well. So things like NewVector is our newest acquisition, which I'll talk about later on in the presentation, which is a fully independent and zero trust container network security platform that integrates with Rancher. We also have various projects that go along the side of Rancher, being RKE or RKE2, which is our Kubernetes distribution. We also have K3S, which is a Kubernetes distribution that Rancher created, but then donated to the CNCF, but we are still the largest contributors to that project. The same with Longhorn. Longhorn is our distributed block storage platform. And that's, again, a project that we donated to the CNCF, but maintain the largest contributors to that project. And then Harvester. Harvester is an interesting one. So one of the largest problems with containerization is, do you run it bare metal or do you run it nested in virtualization? Harvester fixes this by being a open source, hyper-converged platform designed to run on bare metal hardware, meaning that you can run virtual machines and Kubernetes clusters natively together without having to nest them within each other. So that's our portfolio. And what SUSE do, as I said before, we wrap a support wrap around it all. So all of this is 100% free at the point of use. So please use it. It's very good tech. So Rancher, as I said before, in the poll that we had before, I wanted to find out who was actually using Rancher in production, whether that being actually paying us for it, or if that's just testing it or just have an awareness of it. So as I saw, there was 70% of people who said, Rancher what? So this is what Rancher is. So if you're in our community, you would have seen this slide before. It's called our cube cake. And it sort of specifies what Rancher is and what Rancher gives you, as well as how it runs in our view, right? So at the bottom layer, we run on any enterprise Linux platform or enterprise Linux software operating system. So whether that be our own SUSE Enterprise Linux, Rancher OS, RHEL, Ubuntu, Oracle Linux, Amazon Linux, we don't mind what Linux operating system running on. As long as you've got a kernel, you're all good. We actually support any CNCF certified distribution of Kubernetes as well. So that's within our own distributions, RKE or K3S, but also any, as I said, certified distribution from CNCF. So that could even be OpenShift or Tanzu, TKG, or Micro K8. We'll also support that. We also offer full lifecycle management for Amazon EKS, AKS, and GKE. I've mentioned Harvester in the previous slide. So really where our secret sauce is with Rancher. So Rancher is, as I said before, an enterprise container management platform. So it's designed to be able to make deploying applications and actually provisioning Kubernetes clusters easier across multiple pieces of infrastructure, whether that be in the cloud, on-prem, or at the edge. You only need one Rancher management server to be able to provision and manage all of that. Just provides you a little single pane of glass. So what is included in that? So first of all, container security. I mentioned that before. That's new vector, and we'll go into a little bit more detail about that in a moment. We offer a full app marketplace using Helm. So we actually use Helm to deploy out our certified technology partners, like Helm charts. So if you need to deploy things like Datadog or Sysdig, we actually have certified charts available for you to easily deploy down to existing infrastructure or new infrastructure. Just makes deployment that little bit easier. We have a full dashboard and monitoring as well as an observability stack, and that's actually using open source technologies like Prometheus, Grafana, and Alert Manager. And because it's open source, we want you to be able to extend it down to your application infrastructure. It's not just hidden there to be able to run on Rancher. You can extend that down to your applications and monitor them and create alerts based on that. We have integrations for Istio, so we actually offer an support contract. We actually offer an SLA against service mesh for Istio. We have Longhorn storage for distributed block storage. As I said before, that sort of combines multiple disks on Kubernetes nodes and presents in block storage to create persistent volumes. We have integrations into multiple authentication providers, Active Directory, SAML, Okta, GitHub, Ping ID, even just using Open LDAP, you can also use that. But that then goes into our role-based access controls within our policy enforcement sort of side. So you can actually have role-based access control at the global level, cluster level, but even a namespace level. So meaning that if you only want people to be able to deploy an application within one specific namespace, you can do that through our RBAC controls. My favorite policy enforcement and governance tool, if you can have a favorite, is our CIS benchmarking, where obviously you can benchmark your container images against CIS standards to make sure that you're not introducing known CVEs into your production infrastructure. So we can do that all through the Rancher UI. And then the actual management of Kubernetes clusters. So we actually have full Kubernetes version management control. So whether that being upgrading or downgrading Kubernetes clusters, we can do that through the UI or through Terraform. We have a continuous delivery tool set. So that's actually using Fleet, which is one of our projects. And that's the way that we can actually scan Git repositories and then instantly push them down to those Kubernetes clusters, whether it be through labels or through specific Git branches. We can specify which Kubernetes clusters get deployed down to. We can template clusters with no pool management and cluster provisioning as well. So we have multiple node drivers and cluster drivers within Rancher to be able to provision clusters on various cloud providers or even on-prem infrastructure providers. And one of the newest additions to this is actually our bare metal provisioning techniques for edge devices. So we can actually start to provision bare metal devices wherever as Kubernetes clusters without anything on them. So you can have that instantly ready to go. So this is our offerings. This is the open source side of things, which is what's free. It looks like there's a lot more bullet points in the paid version. But honestly, everything that you get in the paid version and in the free version is included in the paid version. You just get support. Obviously, we offer 24/7 support on that. Professional services like consulting, even paid POCs if you want to. And then we also have hosted Rancher, which actually hosts the control plane for you instead. And by doing that, you don't have to worry about deploying Rancher at all. All you have to do is log into it and deploy your clusters, or even import existing Kubernetes clusters to be deployed down to. So what I've been told to say today is that Rancher is now available on the AWS marketplace. So if you want to purchase a support contract, or, which is more interesting, is the fact that we actually have a deployment wizard on AWS, meaning that you don't have to manually deploy Rancher down to multiple Kubernetes clusters. You can go through this little wizard, and what it will do is you'll automatically deploy Rancher adhering to best practices across a 3-node EKS instance, and that's across multiple availability zones. Why is Siri talking to me? I don't need to know what best practices are. The only prerequisites to this is the fact that you just have to hosted zone on AWS, and an IAM role, and then associate that, and then it deploys it all automatically. It's very, very cool. There's multiple videos online showing how it works. It's also completely free, apart from obviously the resources that you use in AWS. So you can just go ahead, use that, and you instantly have a production environment ready to go for Rancher. New Vector. Now this stuff is the new stuff, but it's very cool. New Vector, adhering to, so when we acquired New Vector in 2021, they were a closed source company. And to show that SUSE are dedicated to open source technologies, we released everything that they made. So including all of their patents. So we own nothing. Apparently we don't like money. So that's now all open source. You can consume it all for free. Obviously, again, we have support for it. But New Vector is very special. So New Vector does two separate things. So it has supply chain security, which is pretty traditional when it comes to security platforms around vulnerability scanning, compliance scanning, and admission control. There's nothing really special about this. We do some funky stuff around admission control, being that we can, pass or fail builds through your CI/CD pipelines to make sure that you don't introduce vulnerabilities into an active Kubernetes environment. But our special source is through our runtime security. So we do runtime scanning, that's okay. But what we can do is we can do zero trust controls based on a Kubernetes network. And we can actually do threat-based controls upon that as well, meaning that we actively learn how the Kubernetes application or the application deployed down to a Kubernetes cluster is supposed to behave. And then we can block activity that is not allowed. Obviously zero trust. If you guys don't know what zero trust is, then I don't know why I'm explaining it to you. But yes, it's very cool. That is what we have the patterns around. It's through our Kubernetes DPI, which is deep packet inspection within the Kubernetes cluster itself. No other solution on the market can do that, or in the industry can do that. So our supply chain security is pretty neat. So we have full security. We could identify known CVEs through as soon as the developer commits code. We can actually view it in the CI/CD pipeline as well. So we have multiple plugins for Jenkins, Circle CI, if anyone's still using that, or multiple other CI/CD tools. We can then pass fail builds upon that and then actually scan public and private registries. The reason that you might want to scan a public and private registry is if you're importing an existing application that you didn't make, right? So you can actually scan your bought applications within your private registry and then be able to release push those down to your runtime environment if need be. And then we can do runtime scanning as well. So we can actually scan the running pods within the Kubernetes cluster to make sure that no new CVEs appear. So we actually update our CVE databases every night, and we've got 17 databases that we're using at the moment. And we're constantly addressing more, like assessing more databases as time goes on. I said before, our special source is within our runtime security. So we have two parts to this. We have our threat-based controls. So we can scan, as I said before, against known CVEs. We have data loss prevention. So we can actually prevent credit card numbers or email addresses leaving the Kubernetes network in case anyone does gain access. We can alert you to known network attacks, as well as the OWASP top 10. If you've got any things like SSL injections or anything like that, we can identify those kinds of attacks and prevent them from taking place. And then we can also admission control specific builds as well, as I mentioned before. But the zero trust controls are the interesting bit. So we have automated learning for our zero trust security platform, meaning that there are 3 stages to this. We have discover mode, which means that we sit there and learn about the Kubernetes traffic that's taking place. Then we have an alerting mode, which means obviously this didn't happen before in the discover mode. Do you need that to take place? Do you want to allow it or deny it? And then we have a full-on deny mode, meaning that everything that you have said should take place will take place. Anything else is completely blocked instantly. This allows us to block not only network access, but also processes themselves. I mean, if, for example, you wanted to run an ls command within a specific container or within a pod, we can block that command from taking place. It's pretty neat. The same with file access, because it uses the same protocols behind that. We can then actually export these security policies as code and push them down to other Kubernetes clusters that are also running NuVector. One thing that I didn't mention is that you can use NuVector on any Kubernetes cluster. It doesn't even have to have Rancher. It's down to the Kubernetes cluster itself. You can run it in the cloud, run it on-prem, you can run it at the edge. Any Kubernetes infrastructure, doesn't matter if it's using OpenShift, if it's using Rancher at all, you can run NuVector and it'll be all tickly-boo. Any questions on anything that I've covered so far? Cool. So, as I said before, we're an open source company. So those are our two biggest projects. What I wanted to show you today is a little bit of our projects that we work on in the background. So these are 3 projects specific to Kubernetes. So we've got Rancher Desktop. If you haven't used Rancher Desktop already, it's pretty cool. It's there to replace Docker Desktop. So it's the ability to run Kubernetes clusters on your desktop, and also for development purposes and things like that. So we actually are able to use Containerd as a runtime, or even Docker. So fully available to choose how you flow there. The 2 cool projects is one is Opni, so it's an AI and ML logging tool, so being able to actually view and analyze your active logs within your Kubernetes environment, and then make suggestions based upon those logs. We are working on it to then take actions. So meaning that when you run Opni, we can monitor the logs, learn from the logs, and actually improve the cluster's performance and health. The other one, which I think is pretty cool, is Opinio. So Opinio is a way of deploying Kubernetes applications from code straight to the deployment to the Kubernetes cluster. You don't need to make any Docker files or Docker images. You don't need to learn really how Kubernetes works. If you just want to get your application running in Kubernetes, use Opinio. You just push the code straight through and it will spit out a working Kubernetes environment. Very neat, all free. So that's all the content that I wanted to cover today. But what I did want to alert you to is our raffle, because everyone wants money. So for the people in the room, you can either scan the QR code, or my colleague Charlotte has little cards if you want to go traditional, or you can put your name in and your phone number, and we'll do the draw tomorrow. And what we can do is that you might win £200 in Amazon credit. Not real money. Yes, no, thank you very much. Yeah. How does NuVector help retire compromised running containers? That's a very good question. So realistically, it shouldn't, because of the zero trust controls, it shouldn't be compromised, right? Correct? However, we do have the ability to instantly block those images from running again. Because obviously, actually with Kubernetes, you are running the image of a certain version. We can block that version so it doesn't deploy in that Kubernetes deployment, right? So realistically, you shouldn't have to worry about when it retires, it will block it instantly, and then it won't redeploy that version of that Docker file. Oh, yes, go ahead.
Yeah.
Oh.
Can you? Oh, sorry, go on.
What's the minimum spec for the Rancher Desktop?
You should use the mic.
Good. Can you hear me?
Yes, loud and clear.
So imagine I'm running the Docker desktop, and I go over to Rancher. What's the minimum spec for the machine?
That's a very good question. It changes a lot. I know that it runs on multiple architectures at least. So I know it's running on, we've actually got it working on M1 Mac at this point. So that's pretty cool. But yeah, I don't think I think the spec is at minimum 8 gig of memory. It's not enormous. But we do change the specs quite a lot, so I'm not going to make like a proper comment on it because obviously we're developing it all the time, and the more features we add, the more loaded it gets. So yeah, I would advise you to look at our docs.
Can you hear me?
Yeah.
Oh, that was a great presentation, Nelson, by the way. I have a couple of questions. One is with respect to Rancher. So in the slide, you kind of showed Rancher kind of covers a lot of specs. The ones which I'm more looking at is the security bit, where you have the role the RBAC access. And you also spoke about Rancher being deployed into EKS or any other cloud platform. Now, if you kind of look at any of the cloud platforms, the Kubernetes platform which they provide, they also support an RBAC model. I can talk in terms of EKS, where they provide service accounts and things like that. What is the advantage of me going for the security controls of Rancher as against the security controls which the cloud provides, be it any cloud for that matter?
So it's more around centralized RBAC controls with Rancher. So because Rancher is a multi-cluster management platform and be able to deploy onto multiple clouds, not just one, you would have one centralized RBAC, whether it be using Azure AD or using on-prem Active Directory or Open LDAP, you have a centralized RBAC control to be able to push into Rancher. Rancher does have its own role-based access controls as well, which you don't have to use an authentication provider to do so. But yeah, you can import a lot of existing RBAC controls using YAML as well. So if you do need to import whatever RBAC controls you're using within the cloud providers into Rancher, you can do that.
Okay. Thanks for that. Just leading on to another question. Sorry if you have time. I think I also saw things around, you have network policies being handled in Rancher as well. So there are other components in CNCF which basically takes care of those specific things. For example, you have network policies, Calico and Cilium, which kind of covers those aspects. So how does it different from the already existing CNCF framework, which kind of covers that specific issues? How does Rancher kind of differ from that?
Can you put that into different words? Sorry.
Okay, so Rancher basically kind of covers a lot of features, right? Like pod security policies, network policies, authentication. So it basically kind of covers a lot of aspects. There are CNCF projects out there which basically kind of specifically covers those aspects as well. Like, for example, Cilium, you take a Cilium, for example, it basically only takes care of network policy and things around that. How does Rancher differ from those specific components which kind of takes care of those?
Okay, so the ideology around Rancher is that we don't believe that you should replace anything that you currently have with Rancher. What we want to do is integrate it with it. So because it's fully open, we adopt open source technologies like Cilium, like multiple CNIs, multiple CSI drivers, etc., within the community to make sure it works with your Kubernetes environment. If you guys already have a CI/CD pipeline, or even have existing security platforms that you've got taking place, we don't say you have to rip it up just to use Rancher. You can push in Rancher and then adapt it, integrate the other tools into it as well. So that's the idea, is that we're not there to compete with anybody. It's a complementary technology.
Right. Thanks.
What about Google? Sorry about that. Thank you very much. Now, you just in your main talk, you just listed EKS as the supported version for which you can deploy a lot of things on Rancher. What about EKS? What about OCI? What about GKE?
Yeah. So the Rancher setup image thing that I showed you within the slide is a signed installer from us and AWS to be able to install Rancher really easily onto EKS. But we fully support all the cloud native providers to deploy Rancher 2, as well as deploy Kubernetes clusters down to as well. So we have full lifecycle management and support for EKS, AKS, GKE, but that includes Rancher actually running on those as well. So it's just, at the moment, we've got this easy to use installation button, I'm going to say, or wizard, to deploy it on there as well. But I do believe that we're looking into doing it into other clouds as well. Most likely, in 6 months on the other two.
So in other words, if I went to the marketplace of the other two or any of them, any of the hyperscalers, I can always pick up Rancher there and scale them across from premises to the cloud.
Yeah, so to deploy Kubernetes clusters down to those, you would just put in your API credentials into Rancher. If you want to deploy Rancher on those hyperscalers, you'd have to do it manually. So you create a AKS cluster at the moment, and then deploy Rancher to them. But in 6 months, we'll have that. Maybe it's gone down now. We'll be able to do it automatically.
Thank you very much.
No worries. Does Nevo provide an image signature storage service? Not that I know of, but I could be wrong. So the classic, look at the documentation. We'll reply back to it though. Yeah, if you want to sign up to our raffle, we'll get back to you.
Okay, I think we're good. Whoa. Round of applause, please. All right, we are going to take a 15-minute break now. So we'll come back for 8 o'clock. Because people have asked, the toilets are up one floor in that corner over there. So I'll see you back at 8 o'clock. There are also toilets in this corner, apparently. So they're all in this corner.
Better because it's like, and it's right near the left. So I'm sure there's some sort of skill regulation on safety to get people out.
Let's try it. Yeah. But we need Wi-Fi. Yeah, you need to do Wi-Fi. Thanks. think that it needs to be fine. It's just the Wi-Fi, which I guess it takes the same instead of leaving someone to approve it. Oh, no. It's between a little bit.
It's the sort of thing where
Yeah, you always do it now. I know, I look at it looks like the right amount of chairs. Back again.
All right. Welcome back. Please come in and sit down. We're going to get started on our third talk very shortly. There's a couple of extra chairs here for if you were standing at the back, but please come and sit down, and round of applause, please, for our third speaker, Dylan.
Hello, everyone. I'll just give people a couple more seconds to come back down. So I noticed that in the polls beforehand, the vast, well, maybe not quite vast, but the majority of people were operations people, but also the majority of people said that their last root cause was really simple. What are you doing? We don't tell them that. You meant to tell them that it's all really hard. There's developers here. We can't let them know how easy it is. No, so I'm here to speak about unknown unknowns and how to know them. My name is Dylan Ratcliffe. I'm the founder and CEO of Overmind. Previously, I was a professional services engineer at Puppet. And I'm not going to go too much into my background, but so first, let me start with the story of how a printer made me quit my job. So while I was a consultant at Puppet, I was working for a company that will remain nameless. And the gig was going really, really well, but we wanted a big win before I left. Now, at the time, every single server had a root password, as in a shared root password that when you join the team, they hand down this arcane secret knowledge of the root password, which you're not allowed to tell anyone because it hasn't changed in 10 years and it's not going to change for another 10 years. So definitely don't tell anybody about it. And so we wanted to change that. So our intention was to implement triple SD, which would allow people to log in with their actual username and password and do nice things like remove their access when they leave the company. And so it was all going to be very good. And so we were going to deploy this to production on a Friday afternoon. Now, there was not enough groaning there, but if people have deployed to production on a Friday afternoon, they know it's a bad idea. I know it's a bad idea. And I knew at the time that it was a bad idea. But it was the last day of the project and we really wanted to get a win on the board. And we were pretty confident, legitimately confident. We had done testing in their development environment. We'd gone through all of the procedure and got all of the approvals that we needed to get. So we were pretty much ready to go and we were very confident. So we hit the button and rolled out the change and watched the results come in and everything was coming back green. And so we tried to log in using the old secret arcane root password and I looked away and it worked. And then we tried to log in using someone's actual username and password and it worked, it let us in. And so that's good. So nobody's locked out, but we can use the new system. We can just turn the old one off later. And that was about it. Things were coming in green. We just had to sit there and wait. This is about T-minus 90 minutes from going to the pub at this point. And at T-minus 45 minutes, the phone rang. And unsurprisingly, it wasn't good. So somebody said, hey, nobody in my department can save PDFs. The whole department's at a standstill because we can't save PDFs anymore. And I thought, what? How could we have broken saving PDFs? We touched the back-end Linux fleet. We didn't touch any Windows computers. We certainly didn't touch any laptops. How possibly could we have broken that? And so I asked, what do you mean? Tell me what you do. And they say, well, I go file, print, PDF printer, print, and it doesn't work. And I said, don't you mean file, print, save as PDF save? And they said, no, file, print, PDF printer, print. So it turns out at this company, if you click file print, you get a list of printers, which are all physical printers in the office. And then you get a printer called PDF printer, which we have broken and we don't know what it is. So the job was now to work out what it was. So we did the obvious thing, which was ask around, and nobody had heard of it. But they have a wiki and they do a good job of maintaining their wiki and they put everything on there. So we checked on the wiki and it's not there. But they have a CMDB and they do a good job of maintaining their CMDB and everything's in there and it's not in the CMDB. And so at this point, we were kind of screwed. So we decided that we would just try and SSH to the IP address of this printer and see what happened. And it presented us with a login prompt. And so we put in the password, that password, the one that everybody knew, and it worked. It let us in. And so what came next was a particularly complicated session of infrastructure paleontology, where we were trying to work out how the bones of this thing fit together when it was alive, which is much less exciting and much more tedious than Indiana Jones makes paleontology look. But we got there and we worked out what it was. So it turns out that about 10 years ago, somebody bought a physical server and put it in a rack, and its job was to be a printer, except instead of printing things, when somebody printed to this printer, it would save a PDF and then run a script, and the script would pick up the PDF and move it onto a network share, and the network share was on the NAS, which was mounted to your home directory, which is in your My Documents folder on your laptop, so that when you go file, print, PDF printer, print, it looks like it comes onto your laptop. But actually what's happening is it's doing this horrible dance to this printer and then all the way back around the network again. And we'd broken that, which was critical. So we had to work out how to fix it. And unfortunately, the fix meant changing thousands of permissions on the network share, which was scary. And so we had to work out whether anything else was using this. Is there any other printers or telephones or other things using this insane process? And unsurprisingly, because the printer was almost impossible to find, any information on what might depend on this was completely impossible to find. But by this point, everyone had gone home. So we decided we were just going to make the change anyway, because we couldn't really make it any worse. And we made the change and everything was fine. And so we managed to get it fixed. Everything just started working again. It was okay. But the entire department had gone home for the weekend and they hadn't been able to finish all the stuff that they were working on. And so when we still got to the pub, but we were about 90 minutes late. And so we got to the pub and had a pint and sat down and thought about what could we have done better here? Or could we have avoided this? Or if we couldn't have avoided it, could we at least have done a better job? And we decided that basically we couldn't have avoided it. If future Dylan had come and stood next to me and said, hey, before you do this production deployment, you should check to see if there's a physical server that nobody knows about that's pretending to be a printer that saves PDFs and puts them on the network and goes on people's laptops. I would have said, that's so stupid that if I was to check for that, I might as well just check for every possible thing under the sun and I'll never get anything done. So I'm not going to check for that. And I wouldn't have, even if somebody had told me. So there was no way we were going to not do it. All we could really hope to do was to find the problem faster and fix the problem faster. And what I realized, and the reason that this made me quit my job, I've dealt with more painful things than this, but I realized that in general, our industry is pretty bad at dealing with these sorts of problems. And I thought that I had a way to fix it after having this experience. So I quit my job and I started Overmind. And so, but before we talk through any of what Overmind is or anything like that, we need a lot more background on the problem. So what I'm going to go through is firstly, what are mental models? Then I'm going to talk about what the Stellar report tells us about mental models and how they relate to outages. I'm going to talk a little bit about the enduring legacy of unknown unknowns and how they slow companies to a halt. And then we'll talk about how we can fix it. So firstly, a mental model is what allows us to predict the outputs of a system for a given set of inputs. For example, I have a mental model of how driving a car works. I know when I press the accelerator, the car speeds up, and when I press the brake, the car slows down. Now, I didn't work this out by pulling an engine apart and looking at every single component and making a prediction about how they would work together. I learned this through experience, through driving a car. And so our mental models of our applications and systems are built in much the same way. They're very, very often not built from first principles. They're built from operating the thing and looking at what it typically does when I do this. And so just like no amount of driving makes you a mechanic, no, these mental models that are built from experience are not enough when things go wrong. So Wood's theorem states that as the complexity of a system increases, the accuracy of any single agent's own model of that system decreases rapidly. And Woods himself actually conducted a workshop that delved into a number of outages, which I thoroughly recommend reading the report on. It's called the Stellar report. If you Google that, it's excellent. But they looked into a number of large outages and the roles that mental models played. And what they found was common across every single outage was these 5 things. In every single case, each anomaly arose from unanticipated, unappreciated interactions between system components. There was no root cause. Anomalies arose from multiple latent factors that combined to cause a problem. The vulnerabilities themselves were present for weeks or months before they played a part in the evolution of the anomaly. They were activated by specific events, conditions, or situations, and those activators were minor events, near nominal operating conditions, or only slightly off nominal situations. And in all of these cases, the outage caused what he called fundamental surprise, which is when the situation in front of you refutes your most basic beliefs about how a system works and forces you to rebuild your mental model to take these things into account. These are the unknown unknowns, the things that we didn't know that we don't know. And I don't think that this is a coincidence that in every single one of these situations, it was caused by something that was completely impossible to predict. I think that outages will always happen at the edge of our mental model. with the things that you don't know that you don't know. Because if you knew about them, you wouldn't have got yourself into that situation in the first place. Even if you know that you don't know something about how a system behaves, I don't know how this new version of a database will behave with my application. That is a known unknown. I know that I don't know it, which means I can prepare for it. But unknown unknowns, by definition, we don't know about them and we can't imagine them, like this printer thing. No amount of sitting there and thinking of situations could possibly have generated the printer thing. And so doesn't this sort of mean that the problem can't be solved? If these big outages are always caused by unknown unknowns, how doesn't mean it's sort of an unsolvable problem? And actually it's worse than that. Because as we improve our mental models, we understand and prevent the simple ways that it can break, which leaves the complex ways. So by improving our understanding of our systems and preventing simple outages, you know, disks filling up and things like that, we are forcing our outages to get more and more complex because they will always happen at the edges of our mental models. Because if we knew that it could cause an outage, we wouldn't have done it, or we would have put something in place or an alert or something. However, to our credit, we are probably making outages less common by getting rid of the really simple things, but we're definitely making them more complex as well. And this still isn't the worst part because management haven't got hold of it yet. So we know that outages are caused by unknown unknowns. But think about how that must look to management. We followed all of the processes and something still went wrong. So how do we fix that? Any guesses how management would fix that? We followed all the processes and something still broke? Add more processes, correct. And this leads to a process that ends up basically amounting to getting so many fingerprints on the gun that when it eventually does go off, you can't pin anybody for it. It's called risk management theater. And this is how it works. So firstly, a company experiences an outage and then adds more processes in order to try and avoid that problem in the future. This increases the lead time for each change. Now, compared to high-performing companies, low-performing companies that participate heavily in risk management theater have a 440 times longer lead time, which leads to a lower deployment frequency. A lower deployment frequency means that every change must be 46 times bigger in order to keep up with high-performing companies. Now, spoiler, low performers don't keep up with high performers, but nevertheless, the changes are still bigger. And bigger changes and less practice in doing them means that they are 5 times more likely to fail. And all of the above means that when things do go wrong, they go wrong in a big way and they take 96 times longer to recover from. This is the real demon here. It's this feedback cycle that causes companies to grind to a halt. It's the reason that I quit my job to work on this, because I was sick of seeing people who were extremely capable and tools that were extremely capable being underutilized because they were drowning in risk management theater. But you can sort of see how it would happen. You can imagine if we were to go back to that company that I spoke about with the printer, and I wanted to do a production deployment, there'd be a step where you print a test page on every single one of the printers before you deploy to production. And then you print another test page to make sure it works. And these processes build up like barnacles until you're really, really, really slow. So I just want a quick show of hands in the room of anybody who's worked at a company that was affected by this. Okay, a few. This is a cloud native meetup, so potentially you haven't worked at a bank. But as the companies get bigger, they do tend to, this gets more and more prevalent. If you're a big company that manages to avoid it, you've done very, very well. So how can we fix it? We've got good tools for using our mental models to deal with problems and understand things. If we look at observability tools, for example, they let us see our outputs in detail so that we can apply our mental model and infer what the internal state of the system must be in order for it to have produced those outputs. But they don't really help us build mental models. And we know that when something goes wrong, it almost always goes wrong outside our mental model. So it doesn't really help. They found in that same Stellar report that I mentioned earlier that when things went wrong, the building of mental models work was done exclusively with primal tools like the command line. And so what are they doing when they're using the command line? They're not looking at outputs. They're not looking at logs because they already have tools that do that. They're going to be looking at the configuration, the inputs of the system. And so not only is configuration changes responsible for 80% of outages. Don't quote me on that. It's from Gartner, but I don't think it was very well researched. But I think that everybody has a feeling that configuration changes do tend to be the thing that breaks things. Yeah, so they are where breakages tend to happen, but it's also where all of the, this is how the application is supposed to work information lives. And it helps us to rebuild our mental models. It contains things like, what database server does this point to? What security group is this in, and what are its rules? When's the last time it was changed? What did they change it to? Who changed it? And so if we had tools that monitored our inputs, our configuration, as well as observability tools that monitored our outputs, we'd be able to do things like immediately determine whether a setting has changed, or look at all the settings that have changed since the anomaly began and work out whether any of them could possibly have caused it. We could also build mental models before we make a change. If I have to change a security group, I could discover which components use it, and then what applications those components are a part of, and then build up a realistic blast radius for what changing the security group might actually do. And so this is what I've been trying to solve for the past 12 months. I looked at technologies today, and there's a few technologies that you could use. So Cloud Query is a tool that allows you to look at your cloud infrastructure and dump it into a SQL database and then run SQL queries against it. So you could use something like Cloud Query to dump everything into Postgres every hour, and then you have a historical record of what everything looked like, and you could look at changes or look at how things are related, sort of. You have to do the joins yourself. The same thing could be done as well by just dumping everything from kubectl into a Git repository. That's not very hard. If we just did kubectl describe one of everything and then save that to a Git repository and did a Git commit every hour, we would have a reasonably good history of all of our config. And it sounds kind of dumb, but there's real situations where this would help. For example, do you know how to list all the places a security group is used in AWS? Now, correct me if I'm wrong. I know there's AWS people here. Do actually correct me if I'm wrong, but I believe deleting it will give you a thing that comes up and says, "You sure you want to delete this? Look at all the places it's used." And that's it. And you can't do that in the API. If you want to find out where it's used in any other way, you've got to look and say, like, all right, hit the EKS API. What security group are you using? Find out. So it's very, very painful. But if you had everything dumped into a big folder, you could just go Control F, look at everywhere this particular string comes up, and then look at everywhere it's used. It's not very high tech, but it certainly is a hell of a lot easier than doing 20 AWS API calls and stringing them all together and all that sort of stuff. If you're using VMs, you could use Puppet, Chef, or Ansible to gather information about the server before and after you make a change, so that you could make sure that those changes are what you expected. For example, if a service was running before and it's not running now, was it because you changed the permissions on its config file and it can't read its config file now and you've broken it? And these sorts of checking before and after are pretty easy to implement. kubectl, you can dump what you're about to deploy to before and after and just get a diff. And it helps for a lot of processes that aren't supposed to change anything. Like, I'm updating the version of my dependencies, but everything else should be the same. If you do the diff and suddenly there's a bunch of extra stuff running or a bunch of stuff that's not running that was before, chances are you've done more than update your dependencies. You've broken something. And so these are all kind of possible, but they're not brilliant, and you've sort of got to implement them yourself. But the one thing that they really don't do very well is handle relationships. And so this is what I've been working on specifically. So it's always sort of stood out to me that if you look at a HTTP endpoint, there's some obvious things that you might go and look at next. Like there's a DNS name here. There is a certificate. If you were to just build a tool that works like a web spider and goes and gets a HTTP endpoint and then gets the certificates and gets the DNS and gets the IP addresses and on and on and on, you could build up a graph of all of the configuration through your application, and then you could keep going and keep going and keep going until you've mapped your entire cloud. If you then put that into a time series database and look at changes, you can infer how changes in one thing might affect another thing. For example, if this thing changes, there's a good chance that it'll have a pretty substantial impact. Whereas if this thing changes, quite possibly not. It also, because I didn't have to tell it anything in order to do that, it just spidered. It doesn't need a mental model in the first place. The whole problem with observability tools is that you need to know what you're looking for in order to fix stuff. But we know that when things go wrong, it's outside your mental model. So this doesn't require any configuration to set up. So it can be used by somebody who doesn't have a mental model, like when everything's broken and you're questioning everything you believe. So at the moment, Overmind is in early access. If you want to look at it, take a photo of that. This is the only slide that will be on. And go and sign up there or have a talk to me afterwards. I'm happy to, can't actually show you a demo tonight because it's broken or a startup, but it'll be back tomorrow. But if you put your details in, I'm happy to have a chat and show you what it can do. And I would love feedback. I'd love people to give it a go and tell me what they think. All right, so what did we learn? Firstly, outages will always happen outside of our mental models. They're always caused by something that you didn't know, because otherwise you would have done something to avoid it in the first place. Therefore, tools that require a mental model to use don't help, because the outage has made you question even your most basic assumptions about how that application works. Therefore, we need to be making our systems more discoverable on the fly. When things are broken, we need to be able to discover the config, the changes and the dependencies as quickly as we can. And so what I want to leave everybody with, other than come up to me and talk about Overmind afterwards if you want to, is think about this next time there's a problem. Read the Stella report, STELLA. It's super interesting. Come and chat to me if you have any thoughts. And then, of course, there's questions. Thank you.
Any question?
Okay, I'm not going to try and throw it up in one go. So you go.
Yeah, you described an outage at the beginning. Would your tool have picked that up and helped solve it?
I'm not, at the moment, it wouldn't have picked that up. It's at the moment we support AWS and that's it. So we wouldn't have been able to jump into the Linux server and find out that this thing that was previously running is now not running and stuff like that. It is designed to be an extensible solution though. And I've actually already written an agent for Linux. I just haven't released it yet. But when we want to jump inside of a server and get details about what the inside of the server is actually doing, we can absolutely do that. It doesn't care whether you're inside a server, whether it's querying your cloud infrastructure, whether it's querying DNS. It could be querying like LinkedIn and linking based on your LinkedIn connections. It does not care. As long as you can give it, here's something to discover, and then here's a trail of breadcrumbs to follow, it'll be able to delve in. But at the moment, no.
If you're in an environment that used formal systems engineering, would this fix anything?
Depends how good you are.
Very good and very formal.
Potentially. Potentially it would, potentially it wouldn't. So by formal systems engineering, I assume you mean really high quality documentation up front.
Yep.
And all that sort of stuff. So one of the things that I didn't speak about with mental models is documentation. You can take what your mental model out of your head and put it in documentation, and then people can read it. If you are really good at that and you can confidently say that all of your documentation is correct at the time that something dies, then 100% that would work. I've not been to too many places where that is true. Often the documentation is pretty poor, or it was really good at one time and it's sort of rotted over time as things have changed. So it depends on the quality of your documentation, but there is one thing that it definitely will help with, which is the borders of these things. You won't document all your systems in one document. You'll have a border, sort of a logical border of where the application ends and where some other thing takes over. And that's probably documented as well, but nobody's really checking that the borders match up perfectly. So load balancers are a good example of where this tends to happen. You might have really great application docs, but nobody's really documented how the load balancer is set up because it's sort of another team's job, or it sort of sits between two teams. And you can still get cracks there. Even if your documentation is excellent, outages don't tend to respect those mental model boundaries. In fact, they tend to find the gaps between those mental model boundaries. And so even if you're doing really well, there's a good chance that at those boundaries, there might still be cracks.
Not sure I'll pick him, but
No. Thank you very much. The talk was quite interesting, actually. But then again, I was just wondering whether it wasn't reinventing other analytical tools, what they do, like Elasticsearch or Splunk. Basically, the question is, if you're a Unix systems administrator, whether it's looking at what the daemons, syslog daemons are doing, sending messages to VAR, okay, then analyzing them. Isn't this just, it gives you an overall picture of what's happening with the system. Isn't this just reinventing what they're doing?
It's very similar, and you would use it to solve very similar problems. But the difference is that those sorts of tools are built on outputs, metrics, traces, logs, generally. And this is built on inputs, which is the configuration that you're actually passing to your app, the Kubernetes pods that you have, the AWS instances, the auto scaling groups, that sort of thing. So it's a different data set. Now, you could potentially pump that sort of thing into Splunk, like you could have Splunk periodically read that data, but you wouldn't get all of the links. The linking is something that we do that definitely nobody else does, and is a lot of work to build in the first place. It's like we have to build a library of what the links could possibly be. So you definitely wouldn't get that. You could sort of pipe that stuff into Splunk, but it's not really designed for it. It's designed to look at outputs, and there's not really anything that's designed to look at inputs that I know of.
Okay, thank you.
I guess we can wrap up there. So round of applause, please. For the list. All right, and that is us for tonight. So one more question for the Just Eat folks. What is a good pub around here? It's downstairs, left of the conductor. Okay, the conductor is going to be where we go then tonight. I want to say thank you very much, everyone, for coming out this evening. We'll be back again on the first Wednesday of March. So see you there. Have a good night.
I think I'm going to be the one. I think it's probably good if it's sort of the same person. Yeah, Yeah, thanks very much.